Good day, guys. My name is Latabu, and welcome to another episode of my recap series. Today, we are doing limits, specifically El Hospital's rules. I usually call him hospital, El Hospital, because with him, we'll really end up in a hospital. Okay, let's do it this way. So, let's get to it. So, firstly, El Hospital's rule has to do with indeterminate forms and ways to get around indeterminate forms. Right. So, let's first get an introduction. Let's first introduce ourselves into indeterminate forms. Tongue twisters. Okay. Not tongue twisters, actually, it's my speech impediment. So, indeterminate forms. This are in terms of. Okay, let me just do this. I'm just saying indeterminate products. So, one of them being 0 times infinity. Right, so that's an indeterminate product. At least one of them are bad, and sadly it's just one. Then now looking for indeterminate, unless there is another I do not know about, indeterminate quotients. A few others I do not yet know about. So indeterminate quotients are something like 0 over 0, infinity over infinity, negative infinity over infinity, infinity over negative infinity. One would be saying, it's more or less the same thing. Yeah, but let's be explicit about it. And then indeterminate additions and subtractions. Additions. So one is infinity minus infinity, which might only be one only. Nothing less. Yeah, there is one only. Then what? Now we're going into indeterminate powers. It's 0 over 0, infinity over 0, and 1 over infinity. Please note, zero all over infinity is not indeterminate. Might seem obvious to some, but It's not 200, so just had to specify. Okay, so yeah, those are the indeterminate forms I know of, or rather, revising of. So 0 times infinity is indeterminate, 0 over 0 is indeterminate, infinity over infinity is indeterminate in any form. Infinity minus infinity is indeterminate. 0 over 0 is indeterminate. Infinity over 0 is indeterminate. 1 over infinity is indeterminate. And by indeterminate, what is meant is it cannot be determined in that form. That's why you're learning L'Hopital's rule. So let's jump into it. Get it over and done with. So let's go. So firstly, your first example is going to be limit as x approaches 0 sine x over x. Actually, there's multiple ways of proving this, but we could use squeeze theorem for one. Can we? Yes, we can. So it's we just draw a unit circle, draw triangles, and start proving. So something like this, one triangle, the other triangle, so it's gonna be something like this, triangle like this, and the other triangle like this. You're gonna be gonna start proving this. That's one way to do it. Other way is to just use L'Hopital's rule. So L'Hopital's rule says if you get an indeterminate form, you see we are going to get an indeterminate form. This is an indeterminate form. What we should do in that quotient form, what we should do is treat the numerator and the denominator separately, meaning differentiate the numerator and the denominator separately. Do not use the quotient rule. Just differentiate them separately. So what I mean by that is L'Hopital limit as x approaches 0. I'm gonna differentiate sine, right? And I'm gonna get cos x. And then I'm differentiating x, I'm gonna get 1. Right? And then I'm solving for the limit, cos 0 is 1 all over 1, which is equals to 1. Since cos is a continuous function, that's what we get. And 2. Right? We have limit as x approaches 1, then x all over x minus 1. So this is ln x. We should know that it's 0. Not we should know, that's why you came here. You don't know. Why am I saying that? So why is ln x 0? Well, let's say we had a function, exponential function, right? And it's in the form this. right? And this is 1 obviously because this is an e to the exponent of x function. It's 1 because e to the exponent of 0 is equals to 1. Right. Okay. Now let's reflect this about the y is equals to x line. So a line that goes something like this. Something like this. Then it says so this line is a y equals to x line. If we were to reflect it along that line, we'd get a function like this. See, it's a mirror image. Now this function is ln. The ln function. Specifically, it's ln x. So it's a ln x function. Right. So how do we go about this? So remember, if we have e to the exponent of x is equals to y, and we are reflecting it about the line y is equals to x, we have x is equals to ey. Right. Ready? Then making y the subject of the formula, we'll have y is equals to log base e x, right? Meaning y is equals to ln x. Now in this case, you see our x, our x is, it's gonna be off if I say our x is 0. Our y is 0 in this case, in the reflected function. This is the reflected function. Right. Our y is 0. So if our y is 0, then ln 1 should be equals to 0. See that? Hopefully it's seen. Take it in. Consumption. Okay. So here we're going to have 0 over 0, which is also an indeterminate. So since this is an indeterminate, we need to apply L hospital zone. Tablet. That means you need to derive ln x. When you derive ln x, we get 1 over x. When you derive x minus 1, we get 1. Right? So therefore, we'll get 1 over 1 over 1, which will get 1. Because 1 over 1 is 1. 1 over 1 is 1. See? So, yeah. And to go on, there's actually something I learned that says the factorial of 0 is equals to 1. It's unrelated. It's something that's really interesting because they're saying because factorial is equals to n times n minus 1 factorial, which is quite interesting for me actually. But this information might be useful for someone else. Now let's solve another question of the sort. So we have, this is question 3. Question 3 says, okay, you have limit as x approaches infinity, x cubed minus 2x plus 1 all over x to the 4th plus 1. So you have this, right? Now if you evaluate this, what we get is infinity cubed minus 2 infinity. Our first indeterminate. See, but since we have like a large infinity subtracted by a smaller infinity, then the answer should be infinity over infinity, which is an indeterminate. It's a large infinity, right? So it's the same infinity cubed is subtracted by 2 times of that infinity. If that makes sense. So that means we apply L'Hopital's rule. So which goes something like this. 6 approaches infinity. Right. When I have 3x squared minus 2 all over 4x cubed. Now putting in infinity again will give us infinity over infinity. This is also an indeterminate. Right, so L'Hopital's rule says we apply L'Hopital's rule again. So what do you get? We get 6x, right, all over 12x squared. So in the most basic sense, what we get is 6 approaches infinity. 6 gets into 12 how many times? 2 times. X. So this is what we get. So that means we get this. Which you get this. So this is up. Wait. Yeah. This is our final answer. This could be done in another way. What do I mean in another way? Well, you could do this the following way. You could say, okay, I've got limit as x approaches infinity, x cubed minus 2x plus 1 all over x to the 4th plus 1. So this, you multiply. Remember, if you were to watch my previous videos, I discussed this method. You multiply both the numerator and the denominator by the highest power of the denominator. So that means you will be getting 1 over x minus 2 over x cubed plus 1 over x to the 4th all over 1 plus 1 over x to the 4th. So if you evaluate the limit, you get 0 minus 0 plus 0 all over 1 plus 0, which you will get 0 over 1, which is equals to 0. Easy. Same answer. Okay, so now we're doing number 4. You can pause the video and try it on your own if you want to. If you don't, That's okay. It's okay. Cry about it. So you're gonna get limit as x approaches negative infinity, x squared all over e to x power 1 minus x. So that's what we have, right? Now if you were to evaluate this, we'll get negative infinity squared is infinity, right? And then e1 plus infinity is e to the infinity, right? Right. So as e, function e, is a function ex, as the x value approaches infinity, what does e become? E becomes infinity. So you get an indeterminate form. Here we go. So using L'Hopital's rule, it's hospital. Don't listen to me when I say hospital. When you differentiate, you're going to differentiate the denominator and numerator separately. So the denominator is at the bottom and numerator is on top. So let's start with the numerator. So 2x, right? Yes. And then this one, it's pretty simple. We keep it as it is, right? Times ln e, which is 1, so times 1, times the derivative of the exponent, which is going to be negative 1. Right? So what we get is 2x all over. It's negative 2x all over e 1 over x. Now, what I also do not like about differentiating e is that what I like and do not like at the same time is that e does not change. It's like if lecturer was like differentiate e 5 marks, e to exponent of x, those would be easy marks, plus. So it will be negative infinity over infinity, which is also an indeterminate. So now we use L'Hopital rule. So in some cases you use L'Hopital rule like a lot of times. And you need to swallow that part up. Like, okay, is this rule again? So negative 2 all over e, right? 1 minus x times 1 times negative 1, which will give us 2 all over e 1 minus x, right? Which when we evaluate, right, it will be 2 all over e to the infinity. So what happens when e approaches infinity becomes infinity? What happens when the denominator approaches infinity? When we take a number, small number, divided by a very large number, it approaches 0. And this is our answer for number 4. So let's go to number 5. So number 5 says the following. It says limit as x approaches 0 tan x minus x all over x cubed. So this is what we have. This is x cubed. For those that do not see, let me just try to, x cubed. So we will have something like this. Tan 0 minus 0 all over 0 cubed, which is 0. Will be what's tan 0? 0 minus 0 all over 0 will be equals to 0 over 0, which is an indeterminate. So now we are going to use orbital's rule. So hospital. So something like this. So we're going to differentiate tan. When we differentiate tan, we get secant squared x, right? And then when you differentiate minus x, you get minus 1, right? And then when we differentiate x cubed, we get 3x squared. So in that case, are we still going to get an indeterminate? Let's see. So secant is 1 over cosine. So cosine is like this. So assume this is the origin, something like this. Right? Around 0 is something like this, where this side and this side are equal, have equal area. Okay, something like this. Right. So that's secant will be like this, from here, from the top part, like this, with a few asymptotes by the 0 point, of course, which is by 90, negative 90 in this case. So at this point, our secant will have to be 1. Right. So if we have secant squared 0, secant 0 squared all over minus 1 all over 3, 0 will have 1 minus 1 over 0, which will have 0 over 0, which is also an indeterminate. So we also have to apply our Hospital's rule. Which is going to be as follows. So we're going to say 2, right? So we touch it outside first before we touch it inside. Then we're going to derive secant x. So secant x tan x, right? Derivative of 1 is 0. How you'd like to see that is x to the exponent of 0. So 0 times 1 is 0 minus 1. So it's going to be 0 times 1 over x, which is still 0. That's that. And then you're going to have something like this. And I have 6x. So now 2 times secant 0, which is 1, times 0 all over 0 is indeterminate. Yeah. So L'Hopital's rule. Okay, so now we are forced to use the product rule. So the product rule goes something like this. You have 2. My 2 is a constant. We'll keep it aside. And let me think about something. Okay. Then we'll derive this part. So we are going to derive the first, which is secant. So in derive secant x, what do you get? We get secant x, right, tan x. Then multiply by tan x. And we add. And we keep secant x the same. Multiply by the derivative of tan x, which is secant squared x. Then we divide all of this by 6. Why am I writing L'Hopital? So now the limit as x approaches 0. Let's make it look a bit prettier. It's going to be secant x tan squared x plus secant cubed x all over 3. So what that means is we have secant x, which is 1, times tan squared x, which is 0, right, plus secant cubed x, which is 1 cubed, all over 3. Which our answer is going to be thus 1 over 3. So yeah, that's that. That is that. Now, to do other questions, going to have the following. Of question 6, we're going to have limit as x approaches 0 from the right. Wait, I'm reanalyzing the question if it's from the right or from the left. Okay, it's from the right. X ln x. Okay, so this is what we have. You could solve this on your own if you want, or then see the answer with me after, or we'll just leave it. Yeah, let us solve it together. So we're going to have 0 times infinity. Why am I saying that? Because now the function of ln x is something like this, and as ln x approaches 0 from the right, what we are going to get is infinity. So that's that. So now let's firstly, but now we need to make something a function, because we can't just use L'Hopital's rule when there is a product of 2, when there is no quotient. Let me just be safe like that. And so we need to make that quotient. Now making that quotient will be gambling a bit. But let's see, we're going to see how we could do this. So let's say we have um ln x all over 1 over x. Let's try this one out. Okay, yeah, let's try this one out. I'm trying to predict the answer. So the derivative of ln x is 1 over x, right? And then the derivative of 1 over x is negative 1 over x squared, right? Right. So limit as x approaches 0 from the right, 1 over x, let's keep the negative outside for a bit, divided by 1 over x squared is limit as x approaches 0 from the right, 1 over x times x squared, which is given by limit as x approaches 0 from the right, x squared all over x which is given by limit as x approaches 0 from the right, x, which is given by 0. So it will give us 0. Alright, so that is that. Now for number 7, we have limit as x approaches infinity, e to exponent of x root x. Looks amazing, it doesn't? So given our e to the exponent of x function, which is something like this, doesn't touch the x-axis, please remember that. Okay, let me just draw it properly. Right. And then we have our root x function, which is something like this. So as x approaches infinity, e to the exponent of x approaches what? Approaches 0. And then as root x, as x approaches infinity, root x approaches infinity. So we have 0 times infinity, which is an indeterminate. So what we have to do is form a quotient and then use L'Hopital's rule. So let's form a quotient. And remember, if the quotient gives you a lot of work, cancel that. Wait. Be careful what you say. If the quotient gives you a lot of work, try it another way. And if it's still a lot of work, continue with the one you started before. But if it's small amount of work, that is the right way. Yes. Hope that made sense. E to the exponent of x. Alright, so now L Hospital's rule. We'll have limit as x approaches infinity. Now here I tend x to exponent of negative x. I tended to this because tended into this and multiplied it by root x. Right, so I hope that's okay. Okay, sure. Now we are going to differentiate with x, which is 1 over 2 x to the exponent of negative 1 over 2. Right? And then e to the x is just e to the x times 1 times 1, which is just e to the x. Right, so to make this look a bit more prettier, what we have is 1 all over 2 root x times e to the x. So yeah, so we're going to have 1 all over infinity times infinity, right? And infinity times infinity is not an indeterminate, right? So we have 1 over infinity, which is equal to 0. Hope that made sense. Just a few more questions and then we will be done. Okay, let's do a few more questions. Now, in this following question, we are doing the indeterminate forms of differences, and in this specific scenario, so let me save that for another video. Thank you for watching this. I really appreciate it. Make sure to like and subscribe, and yeah, have a good day.